Zangpo and welcome to this program. Well, we are here at Fab Lab Bhutan in Thimphu, and here with me I have Mr. Raptin, who is the manager at Fab Lab Bhutan here in Thimphu, and he will be talking with us what Fab Lab is all about and when it was established and what are some of the activities they carry on day to day here in Thimphu in the Fab Lab. If you can tell us what is this Fab Lab all about and when was it established here in Thimphu?
Yes, sir. Zangpo. First of all, I would like to thank BBS for coming out to Fab Lab and covering up all the process, what we are doing so far till now. So to start, to go with your question, so Fab Lab is the education outreach components for MITs, for Center for Beats and Atoms. It's the extension of research in digital fabrication and competition. So Fab Lab is the global network of local labs enabling innovation by providing access tools for like digital fabrication. So Fab Lab is not just a place, it's a movement and generation of ideas from one place to another. So basically like Fab Lab, it connects people from one place to another. So regarding the Fab Lab Bhutan, like after more than like 4 years of intensive research, which was led by Mr. Song Hendup, who is based in Denmark. So with his lead, we are finally able to bring Fab Lab in Bhutan in like, we started in 20 July 2017. So right now we are running for like almost for like 1 year.
Okay, now who all shows interest to create products here in Fab Lab?
So like entrepreneurs, innovators, students, like civil servants, lots of people, even from like younger people, they come out here to learn and explore what we're doing.
Ever since the establishment, what were some of the achievements or what are some of the things that you carried out in the last 1 year yet?
So like actually like for REST Fab Lab, 1 year, almost they take almost for like 1 to 2 years to establish the entire capacity of Fab Lab. But regarding out here, so like we took a very like daunting task of the government. So like right now it's like officially it's not declared what we are doing. So like right now we are building a project. So it's called Fab 2.0. It's a Fab 2.0 is the replicating of machines that we have out here. So with the core machine out here, we are replicating different types of machines. Moreover, like with the help of 3D printers, we have like helping lots of, especially like recently we helped like some people from hospital. They want to print some like bottle lid to help with to pass the blood for the dialysis. So we helped him to print that bottle lid. Moreover, like we have been helping entrepreneurs for like some students from RTC. They came out here to like they have like they came out here to make different types of products.
Okay, now what are the areas or fields where Bhutan can benefit from creations or manufacturing here at Fab Lab?
The equipments that we have out here, it's the 21st century equipment that we have. So we can make almost anything out here. So the only thing is you have to think it, you should have an idea. So we will help that idea to turn into reality by giving the platform.
Which areas do you find very much relevant for Bhutan at this time?
So like right now is the time of changing of like industrial revolution. So more like every country is like, initially the Fab Lab, actually it was born in like 2005. In 2005, the MIT, the Professor Neil Grushenfeld, who is the father of Fab Lab, he started the Fab Lab in 2005. So like after more than like after 12 years only, it's reaching out here in Bhutan. That's when Bhutan is lagging behind compared to rest countries. So now with the time changes, now even like Bhutan, we are able to cope up with them. So now we started to follow their footsteps.
So you think Bhutan is catching up with the rest of the Fab Labs around the world. So who are the developers or employees here at your Fab Lab? Do they come with the ICT background, or is it that they come here and start from the scratch?
So it differs. Like some they have like electronic and communication background. Some they are like they just pass out class 12. So it's not mandatory or necessary to have like ICT background to learn in Fab Lab. So until and unless you are very interested in this thing, you're passionate about these things, then anyone can come and learn in Fab Lab.
So where do you get funds from? Because Fab Lab, as we see, is got to do more with the ICT, and as we know, or as we see, ICT seem to be very expensive, even to own a simple mobile phone or even gaming consoles for kids. They are quite expensive. So where do you get funding to manage all this, your lab?
So the entire equipments and the resources, materials that we have out here is whole equipments have been donated by the Dassault System SolidWorks. So it's a software company. So they have been like very privileged to donate all the equipments out here to Bhutan. Moreover, like MIT, the Massachusetts Institute of Technology, they're the one who came out here last year to install and commission the Fab Lab. So like for 1 year, from last year till this year, we have been supported by Buddhist Danish Association in Denmark. They have been helping us to run the lab. So for the upcoming plan, so we have been approached different organizations to help to run the lab.
What is their response like when you approach different organizations? And also, do you have support from the government? Yes, and also, do people understand the importance of ICT and also the Fab Lab here?
Our government, the present government, have been very like helpful to us. Like moreover, they have been very like they've been given us space at the startup center in Changsamto incubation. So next month we will be shifting up there with all the equipments. So for 2 years we will be running from the startup center.
Now very popular with the ICT and also in the recent years is the 3D printing, which Fab Lab is also using or embracing. What is your concern when it comes to 3D? Because there is a concern around the world because with 3D printing they can also produce weapons like guns and all. How is it here in Bhutan?
So it's like we can make almost anything in Fab Lab, but it says we shouldn't conflict the user. So the user itself shows that like these things are not like allowed to make out here in lab. Moreover, like the 3D printer out here, it's like surveillance on the CC camera. So we know what they print out here in the lab.
Okay, thank you so much for your time. Now I would like to go around and see what activities are being carried out.
This one we call it LitterBits, and LitterBits is a new city-based startup that is a library of electronic modules for prototyping and learning. So each modules are pre-engineered, pre-assembled, which ranges from very simple like motors, sound, sensors to very complex like wireless radio frequency, programmability and cloud connectivity. So each component is snapped with the help of magnetic properties, and there is no chance of getting short circuit and no soldering is required. So I'll show you one simple demonstration of LitterBits. So this is it has got 4 bits which is indicated with the colors. So blue color is for input, pink is blue power supply, pink is for input, orange one are the wires and the green one are the outputs. So here is a simple, it's a power supply, pink is the input and the numeric display is the output. So I am using as a temperature sensors as an input and output as a numeric display. So here it is in the 2 mode, Fahrenheit and degree Celsius. So I have switched to the degree Celsius, now it's at 23 degrees Celsius. So it's a simple module and we can make a lot of remote control car through Bluetooth, and these are the control car. It's made by the kids.
But when the kids come here, do they do it yourself or you give some instruction?
We have this kind of little books where they can also do it on their own.
So we have a guidebook
and all the members can guide them.
Let them memorize all the components and explain functions of the component. Then we give them the project, something like project to build something like this.
Is it for free? Anyone can come here, or do you?
Yes, little kids can just come and just play with all the components, and that's how they develop all the sensors with all the sound and everything. So that's creativity.
And what is this?
This one is for our Fab 2.0 project. As managers already mentioned, right now we are focusing on the Fab 2.0 project. So I'm doing on the CNC machines. So this is the overall model of these CNC machines, and we are just stuck by one component, and everything is ready right now. Everything just after that assembled, only after that component arrives, then everything will be ready. This is
what will be its like usage? Where are you going to use this?
It will be used for making the signboards, cuttings, signboards and tables, furniture, things like it will be all done by the machine side, every designing and all this automatic.
It can also build houses.
Build house, yes.
See
through. So we don't have to put nails here and there. Everything we can design and everything can be interlocked. So PyTop is a modular laptop. It's a built-it-yourself laptop powered by Raspberry Pi. So it is the two types. There is a PyTop seat. We call it a modular desktop, and this one is a PyTop modular laptop. So basically, PyTop is to learn on the physical computing things and the coding.
But as we see, it looks like any other laptops. What's the difference?
PyTop is because it's powered by the Raspberry Pi. So main processor is the Raspberry Pi. So from that it derived as a name as PyTop. And the difference between the other laptop is that in other laptops we can't do the physical computing. We can only learn the coding things, but we can't execute the output in front of them. So this is something like where we can learn the coding as well as we can see the output in front of us. So it comes with the 3 accessories. So it is a inventor kit where all the electronic sensors and the components, all the wiring and all will be here. So this is for the learning the electronic things, and this one is, we call it a PyTop Pulse. It's a 7x7 LED matrix, and here is a small microphone, and it comes with the PyTop speakers where we don't have inbuilt speakers, but we can plug and play.
It's a precision milling machine. It's like it is also called a CNC desktop. CNC means a computer numerically controlled machine. So like from here we can print a circuit boards. Like usually if you open any kind of electronic gadgets, be it a TV remote or a calculator, inside there we will see one green board. So that is known as a PCB. So we can print that kind of circuits here. So this machine will just print this kind of traces, and so pins and IC we have to manually do it.
This is like where you can program it, where in your phone, computer, everywhere we have this circuit board. And this we can do it here in Fab Lab. We can program it here.
These are curved by this machine?
Yes, these are like copper plates. So he'll demonstrate one.
This can curve or print on any material?
Apart from these circuit boards, it can even make to do woodworking and acrylic working. So we can even do a wax molding. So this was printed from here. So we have to design the design, and then we have to just transfer it through the computer. So it will automatically do everything. For the past 12 months, I have been doing research on this and designing, programming, everything. So then after that, this is what I have come up with.
This is what he has made, replicated that machine here. So it functions are the same.
Except for the overall design, so it is just open and it is just closed. So all the materials we have used here is a locally available material, except for these motors and rod we have imported on. So it's very hard to get these components. So we have to order from China, US, Bangkok. Then it takes a lot of time. So there we took a lot of time.
This is a 3D printer. 3D printer is generally an additive manufacturing technology. Well, it creates a 3-dimensional physical object from a digital design. Well, there are many different types of printers and material to print with, but here we use the material we use for this 3D printing is called filament. It acts as a feedstock for this 3D printer. This filament is generally made out of waste plastics. Well, about the designing, we need to design a model in a 3D designing software in the computer, and then we'll have to fit it in a USB drive, and then we'll have to fit into this 3D printer to print it. Right now it is on the process of printing. These are some of the models printed out here. This 3D printer is basically called additive manufacturing technology because it adds layer upon layer to complete the physical object at last. Well, these are some of the models printed out here in this 3D printer. And these are some of the working models printed out here in this 3D printer.
This is a stethoscope, and it functions as good as any stethoscope. And then later we can make it here in Fab Lab, which is very affordable. We don't have to import from outside.
Like this filament which she says is a waste plastic. But who produces it? Where do you get it?
We usually import it from out country. And there's one guy here in Bhutan who is designing a machine where we can actually, produce this filament out here in Bhutan.
So what would be the maximum or biggest size?
Well, there are many bigger printers out countries, but here we have a small printer. The maximum build volume for this 3D printer is 20 by 20 centimeter, and about the height it is like 50 centimeter.
Right now, this is initial stage, the first phase. Yeah. So later we'll have bigger machines where we can print bigger objects. We can also do a 3D scanner.
Yeah, not about the designing. We have also this 3D scanner where we can scan the object as well as face of a person, and then which automatically converts into the digital file, and then we can print it out here in this printer. These are some of the models.
Okay, who designs this on the computer?
Well, we design. Actually, like the beauty of this 3D printer is like we can actually create an object what we imagine. It can turn our imagination into reality by creating our
It becomes physical.
Physical solid material. Yeah, we can actually see and touch our imaginary model.
Who controls the quality?
Quality, we have this printer controller software. Like first, we need to design it in a 3D designing software. Like there are many 3D designing software, but among us, we use Fusion 360 to design our model, and then we put it into our 3D controller software, and then from there we need to set the right settings, print quality, and then it will come exactly like here in this 3D printer.
But is there an agency or organization who actually certifies for the objects or whatever you print here?
No, there are no
so far.
Okay.
Okay, please tell us about your creations here.
Hello everyone. It's also the one of the part of the a major project we have doing here right now. We are replicating the same machine out of this 3D printer. Some of the all these printable parts, like this green one, orange, and all this gray color, blue, we have been designing here ourselves, and we have printed in our printer only. Only these metal parts we have exported from the other country. It will print same machine. It will work same as these machines. Our dimension will be same as this one. X-axis and X, Y, Z, and all it is same like this one. It can print maximum size of 200 mm in X, and in Y it's same like this. It will print a maximum of 200 mm size. For the just now we are still doing the process of this one. Mechanical parts we have completed almost 90%, but for doing this one we have to, for the calibration we have to do the right setting of this one. For being all of us for the first time, and we are having tough time to build this one. But mechanical parts we can build with the help of other friends. For the calibration we are still under process, but some layers we can print just now. We can show this. we have said in the G code this is called the extruder. This one is a heat bed. We have maintained in the G code first we have to heat this extruder till 200 degrees Celsius. Then it will heat this bed. Then only it will start printing. Right now it's in the process of heating extruder.
This machine is called vinyl cutter. We can use this one to make the stickers, and we can even use this to print the shirt. Most probably we print the t-shirts we just say it as a screen printing. First of all, we cut this sheet, and after peeling off the unwanted portion of this one, we put this onto the frame, and on frame we can pour some person color, and so we use this one to print the t-shirts and all. We have like last time we have printed this t-shirt for youth awards.
Well, this is an embroidery sewing machine. It is also a computer controlled, just that we have to do our design in a computer and then we'll have to fit it into a USB drive. Here we have a place to fit our USB drive, and then we'll just have to select our design. Well, this is a screen display. We just have to select our design and then press command. The machine will get turned on and it will work automatically. To explain some of the working of this machine, well, we have this place where we can put our thread here, and then it has all this instruction given out here, and then we just have to press the print command and the machine will do everything from here. These are some of the witness design printed out here. About the color, like here a green part, I mean, we just have to fix it in the, I mean, we just have to set the color in our computer, and then it will show, I mean, the display will show that they will tell us what color to use. Like for example, here we have this green. It will show green color, just that we have to change the thread manually by ourselves. That's all.
This is called the laser cutter, epilogue laser cutter. It is of 40 watts. Its power is 40 watts. We can cut through like 6 mm of acrylic sheet, cardboard and wood. Most probably we use this for engraving the photos, and we even made the mementos, and we can use this to print, and we can even 3D relief from this machine. These are some of the products that we made from here. So this is also made here. And so I want to demonstrate a little working of this machine. So first of all, we have to design whatever we want to print out here, print in this machine. So I have the design here, so I'll just directly print this one.
So we can also do 3D any printer here on the slate.
So this is how it works. In the current project Fab 2.0, I along with my friend Kinzang Yeshey, we are working on the same machine. We are developing the same machine of 80 watts, which will be the double the power of this machine, same machine. We don't say that we cannot say that we can make the machine better than the one in the market, but we are replicating the same machine that can be functional, which can be used in our local.
We are replicating this machine of 80 watt. So this machine is of 3-dimensional, mainly X, Y, and Z. So the laser light that is there is converted into the power that is generated is converted into laser light, and the laser light is reflected into the mirror. So it basically works with the principle of total internal reflection. So it hits the mirror down there and reflect to the mirror second, and it will finally reflect to the mirror 3, and finally it will be coming into the surface. So the working area of this laser cutter is of 3 by 2 feet, and the overall size of this machine is 150 centimeter by 90 centimeter. So as we know that Fab Lab's aim is to think it, make it, and share it. So we thought now we are making, and after making it, we are going to share it to a global network known as GitHub. It is an open source network where people can have access to it. So we are going to share it to that network. The function of this machine is same as the earlier machine, that is of 40 watt. It is just used for cutting, engraving, and making 3D reliefs. So we have used this timing belt and pulleys for moving X and Y, and sprockets and chain for moving Z axis. So this is how it works. So we just have a small controller that can move the axis. So this section is called molding and casting, where we replicate the original object into multiple objects. So we use materials such as silicone, and many like this kind of object, original object, can be replicated to duplicate objects like hydro stone and all. we can make multiple objects out of one object. So these are some of the examples, and this is the mold for this object. So we have made mold for original object and casted this one using hydrostone. It takes like we mix chemicals like part A and part B. So after mixing the chemicals, it takes like 5 to 6 hours, and after that it even takes more time, but like 5 to 6 hours is like average time. So this is like part A and part B. We mix this kind of chemical and make these molds. So we make molds for different like silicon, aluminum, and like even the plastics and all plastic. So we have made this mold for like chocolate, this chocolate design.
Anyone can do, all the members, they know how to do the mold and cast. So they have helped with many college RTC and to make like chocolate molds and like some other covers, models, and they have helped with the students with many projects.
So this is a drone where it's like it's running through the battery. So the outer bodies are all designed in 3D printer, and this is the main controller which can control the speed and like balancing of the drone. So using drone to fly drone, we use this remote control to fly the drone. The function of this drone is to deliver the medicine in like remote areas like south and like north part of the Bhutan, where there is limited hospital. It is like the drone can fly using the GPS system, where like from one station to another, just people can fly drone from Thimphu to Gaza using like GPS station. They can just fly and like the drone will reach there. So it uses the GPS system.
Basically, this CNC router is a computer numerical control system, and it works on 3 axes, X, Y, Z, and it has the bed size of 8 by 4 feet, and the spindle power is like 18,000 RPM. It means like 18,000 rounds per minute. So basically, what we do here is like we do engraving and cutting. So the software that we use for designing is like CorelDRAW and any 3D software. So basically, it's like it converts any 2D or 3D models into 3-dimensional coordinates. So now currently we are using this machine to print parts for other machines that we are replicating for Fab 2.0. So soon we are going to replicate this machine as well. But currently for that machine we have like completed almost 80% by designing and programming. The only part that we are left is like we have to cut the metal extrusion, which is quite big. So for that we need like a fiber laser, which has a capacity of like 3000 watt. So we are currently talking with AMC and FMC. So once we get the order, then we can cut the parts.
So on what materials do you think you can engrave or cut?
It can engrave on any kinds of material like wood, marble, steels and all. So these are the few things that we have designed. So this is a stool for the lab. For this we haven't used any nail interlocking. So I have just uploaded the file. So now I have to start the spindle. So once the spindle turns on, then we have to press OK.
So this one is the smart beehive. It was like printed and made by CNC. So the most interesting of the hive is that Fab Lab Barcelona, they have developed a sensor to monitor the health of a hive, not the bees. So like the sensor will able to know how many of bees have entered in the hive, or whether the hive is it's whether it's ready for honey or not. So like the sensor it's like connected to your phone through Wi-Fi. So like after like the hive gets full, the farmers they get an SMS from the sensor. So then he will be able to know whether the like hive is full or not. So this is the main function for the beehive sensor. Moreover, like in today's time, we don't have a sensor for the hive. So like farmer, they take extra burden to check whether the hive is full or not.
So like it's called smart greenhouse. The reason why we are calling it smart is that it is based on sensors. So like whatever it does, it's all automatic. Like it can automatically maintain the required temperature, humidity, light, and moisture. So like if the moisture goes below the required level, so like it will automatically water the system inside the system. So like likewise, so it will control everything. So even light, temperature, like it will be fixed in the fixed temperature range. Like if the temperature is like between 20 to 25, it will always remain between the 20 to 25 every time. Like if it falls below, then it will automatically like increase the temperature. If it goes beyond, it will cool and it will remain in between the range of 20 to 25. So like likewise, so it will able to grow the plants. Like if it takes like normal plant, if it takes like 2 months to grow, then it will faster the growth rate. So like it can like a plant can like give fruit within a month or half months. Likewise, we can increase the growth. And secondly, so like it will able to help the farmers to like increase their annual income. So like because like if the tomato takes 2 months to grow, then we can grow a tomato in a year like 5 times in a year. It's like it will really help the farmers. It's like, and from this small display, like we can monitor the like current temperature, like all the conditions in the house. It's like it's just a prototype, and like we have already tested once, and it seems like everything's working fine. And soon we are going to like make it in a little bit larger scale and see then how it will work. Then if it really works, then we're going to implement in the real field.
Thank you so much, Jason, and also Madam Karma, for your time showing us and explaining everything about Fab Lab Bhutan. And it has been an inspiration for us to understand what Fab Labs does here in Bhutan and rest of the world. So I'd like to thank everyone for watching this program. Thank you.